Very good morning, students. So welcome to prestigious Focus C and IIT NEET Foundation program by Krishnamani Talent Schools and the Mastermind Schools. So once again, I welcome all the class 8th students for today's session. So this is the new week, new day, new chapter. Of course, I am old only. New chapter we are starting today after completing the first chapter measurements in the entire last month. Now we are entered to the kinematics, which is one of the important chapter in our physics, which plays very important role in understanding the other chapters of physics, which explains about the motion of a body, right? So before that, you can see on the screen, my subject is physics. We are in class 8th, our new chapter, the new second chapter, kinematics. And today we are in the session number 1, the first session of kinematics. So before knowing about what is kinematics, we should know about some more important concepts. Some more concepts should know, then we'll enter into the kinematics, right? Because you already learned this part in the 6th and 7th classes in different name of motion or motion and time. Come in regular syllabus or IIT Foundation. But now the new name is given, kinematics. So you should understand what is the technical name, scientific name of the name called kinematics. Okay. Are you ready to learn about kinematics? Okay, now we can see this is the wonderful. See, physics deals with the two parts actually. This suppose after top of the mechanics we have physics. So in physics deals with the two parts. One is mechanics. The second one is energy. You know, physics is a very big branch of science. Very big branch of science, which has most applications in our day-to-day life. In that, first part is completely about the mechanics. Mechanics is nothing but not a scooter mechanic and car mechanic. It is a completely dealing about the motion of a body. So this mechanics is again 3 types. 1, 2, and 3. In mechanics, we'll study 3 headings. One is kinematics, second one is dynamics, and third one is statics. Statics. Try to understand. Mechanics is a branch of physics which deals with the motion of a body. No doubt, motion. Study about the motion we'll learn. Study about both rest and motion. We'll study. And one more important, when body is in rest or motion, there should be some cause. We'll learn about cause also. Cause. What is the reason for motion? Suppose you are simply standing like this. Can you move? We need to apply some force. So the cause is nothing but force. So these 3 terms we learn in the entire mechanics. Why body is at rest? How body is moving? What is the effect of force? That is studied on 3 headings. For example, kinematics, what is our topic, deals with the motion of a body. We are not considering without cause. We are not considering the how body is moving without cause of motion. Here we are not discussing anything about the cause. Means we are not discussing anything about the force. But here in dynamics, when you come to second part, we'll discuss about motion only, but cause also. But with cause. How body is moving. Then here only the word force is derived by Newton. Newton's laws will come here. And here about static, study only about the rest. What is rest? How body is at rest? All these things we study under statics. Statics is study about the body at rest. Kinematics is study about the body is in motion without cause. Dynamics is the study about motion with cause. What is the cause? Without cause, body cannot move. Na? There should be some force to move the body. Such a force is nothing but a cause of the motion. Right? You can take this T diagram. You can note down. Open your notebooks, all of you. Just take down the basics of this. Basics of kinematics. Right? So mechanics is divided into kinematics, dynamics, and statics. Okay. As it is written in brackets, motion without cause. Without cause. C-A-U-S-E. Cause means without any reason. Why they are happening, we don't want. We don't want how they are. Okay. Then dynamics is also study about motion only. Study about motion with cause. We'll study about the cause also. That is, we study about the force. That's why we got the 3 laws of motion. Statics is nothing but study about rest. Okay. So note on this first page number. You take the lesson name, kinematics, heading, chapter number 2. Right? You write the date also, 6th August 24. And if you want, you can write even week Tuesday. And you can write important points or key points. Mechanics and divided into 3 parts: kinematics, dynamics, statics. So we'll come across. When you go to the higher classes, 9th, 10th, you come across about dynamics and Newton's laws of motion, where that all comes. In kinematics, will come across only about motion. What is motion? What are the types of motion? And what are the physical properties when come across motion, like velocity, speed, acceleration? All these things, terms comes in the kinematics. So many mathematical formulas also will come. It's a very big branch of physics. Almost 50% of physics is covered by mechanics only. Remaining part is energy, electricity, heat, light. All those comes in the second part of the physics. Right? So this is about the background of the kinematics. You can say background. Because when you are discussing about any topic, you should know about the background. Without background, you cannot move forward. So before knowing about kinematics, where kinematics is started, we have to discuss. That is the part of mechanics, which deals with the motion of a body without cause. Motion without cause. This is motion with cause. We'll study about motion as well as we'll discuss about the cause also. Here we'll discuss only about the rest. Why body is at rest? What is the reason for rest? Whether body is moving, any force is acting on a body or not. Everything we'll discuss on the statics. Right? Clear, all of you? Shall we move forward for next slide? Right. Very, very basic information about the kinematics. Now we'll come to our chapter. So once again, little more explanation. You can note this also points. So before, see, first, the statics, which deals with the forces acting on and in a body at rest. Suppose you may be suppose a body is here. I placed one book here on table. Book on table. Okay. When book is placed on table, it is there for long time. Long time. Today also there. Tomorrow I came, book is there only. And after 5 days, book is there only. What we can say? Book is at rest. Correct or not? Right? Suppose in place of that, there are some force acting. We are applying force from here. force from here, force from here. All equal forces. Then also body is at rest only. If more force are acting on a body, body is at equilibrium or rest. That is also rest. Either no force is acting or many forces are acting in the opposite direction. In both cases, body can be at rest. To study about that rest only under various conditions is called statics. Right? First point. Second point, C, kinematics, which describes the possible motion of a body or a system of bodies. How body is moving. Discuss about, because there are so many types of motions are there. In case of motions, in our day-to-day life, you can see so many types. Suppose fan is moving, one kind of motion. A person is going by bike, one kind of motion. A person is going by car, different kind of motion. Earth is revolving around the sun, one kind of motion. When you go to the exhibitions or circus, you can see giant wheel, one kind of motion. So many types of amusement parks are there, where you can see so many types of the play items. They all have different types of motions. Swing is there. A child is swinging on a cradle. One kind of motion. All these are the different types of motions which comes under kinematics. Right? In that, one more kinetic also there. It's only about motion only in a particular situation. And dynamics, study of the motion of the body under influence of force. In dynamics, we'll discuss about force also. Force comes into play. First, they started studying only about motion. Later, Newton, anxiously, with very much anxiety, he wanted to learn how the body is moving, why body is changing the position. While knowing about that, he discovered the word called force. That force word gives very big branch of physics. Newton's laws of motion. Totally it is about the force only. Right? So write down all the 4 points as it is. Please take your time to copy the points as important points. After that map, you can write down these 4 points. First, everything is clear, I think. You can see clearly. So all these are the basic points before going for the chapter. So after these 4 points, we'll study about the kinematics, that is motion. We'll recall what we learned in the 6th and 7th classes. There are various types of motions are there in our day-to-day life. After writing these 4 points, I'll show video for you where you can see the different types of motions we'll come across in our everyday life. After that, we enter to the extension of the chapter, right? First, to complete these 4 points. Good to see Dulapalli, Krishnaveni, Navanita Garu, I don't know what is the school name. Krishnaveni Terrace School, Ramannapet, Ramnagar, KTS is there, KTS Gudimalkapur, KTS Kishanbag, Jahanuma, Ramnagar High School, ECIL, all KTS. Good. It means Ramannapet maybe. Ramannapet, KTS. Good. Just mention your branch also, including your school name and branch. Whether it is a KTS or TMMS, you can write a short form also. So that you can give the attendance, we can understand how many are appearing. Right. First, you write down the 4 points, then I'll move to the video. Later, we'll go to the chapter. Kinematics in details we'll discuss. Jogipet, join now. Please try to join before the time so that you can understand. This is a new chapter, so you should understand from the beginning. Four points note down as it is. These are the 4 parts of the mechanics. Of course, kinetics and kinematics are almost same. There are 3 major parts: statics, kinematics, and dynamics. Already statics we learn in 6th, 7th classes about the rest of the body. Now we are going to learn about kinematics. When you go to 9th class, you learn about the dynamics, where Sir Isaac Newton's the famous laws will come. Right. Just let me show you one video on motions. What way which already you learn in the your lower classes. Just I want to show you the various types of motions you can present here, right?
Hi, today I'm here to discuss with you the various types of motion. The whole world is in some kind of motion. For example, a cyclist going on a straight road, the blades of a moving fan, a child on a swing. They are all regarded as being in motion. But we can see there is some difference in their motion. The cyclist is moving nearly along a straight line. The blades of the fan are going round and round about its central rod. And the child? The child is swinging to and fro in a regular manner. We thus realize that motion can be of different types. So what are the types? I begin with rectilinear motion. An object is said to have a rectilinear motion if the changes in its position are all along a straight line path.
Straight line.
See these examples.
Marching.
School children marching on the Rajpath on the Republic Day. Motion of a falling stone. A motorist going straight on a straight road. Striker. Motion of a striker in a game of carom. In all these cases, the objects concerned are moving along a straight path. We call such a motion as the rectilinear motion.
Straight line motion.
Next, curvilinear motion.
See.
When an object moves from one position to another along a curved line, the object is said to have a curvilinear motion. Let us see the examples. A boy is standing on the bank of a river or a pond and he's throwing a stone into it. So how does the stone move?
See how
it moves into a curvilinear motion.
Like this.
Another one, a bus moving uphill on a zigzag road. The motion of the tip of pen while writing are examples of curvilinear motion. Rotation and revolution. Let us explore one at a time. Rotation. An object is said to have a rotational motion if it keeps on moving round and round or keeps on spinning about some definite line or axis without changing its place. Examples. Look at the blades of a moving fan. They are seen as moving but are clearly not moving along a straight line path. A potter's wheel. The wheel of a sewing machine. A child on a merry-go-round.
It's called merry-go-round. You can see
in all these cases, the objects concerned are changing their positions with time, but are still effectively at the same place. We call all such motions as rotatory motions. What about the motion of the moon around the earth, or the earth around the sun, or the motion of the hours and seconds hand of a wall clock? Is it rotation? It is revolution. So what is revolution? The motion of an object moving around a central point, changing its position continuously, usually following a nearly circular path, is revolution. Here, the objects concerned are not moving in a straight line, but are still changing their positions continuously. They are moving in a nearly circular path about a central point. Sometimes, an object keeps on moving in a perfectly circular path. For example, if a ball is tied to the end of a string and the string is whirled round and round, the ball moves in a circular path. We then call such a motion as a circular motion.
Người Pháp gãy ní. Zero.
Periodic and non-periodic motions.
Very interesting. See.
This is interesting. Listen carefully. The type of motion which repeats itself after a regular interval of time is periodic motion. Examples: the motion of the earth as it revolves around the sun once every year. Motion of the hands of a clock, which repeats itself after a regular interval of time, like 60 seconds, 60 minutes, etc. And non-periodic motion. There must be only 2 points we should consider. Either the motion does not repeat itself, or does the repetitions in a random, irregular manner. Examples: when a person speaks, like I'm talking now, so my lips are moving. This movement is as long as I am speaking. When I stop, there is no movement of the lips. The movement occurs again when I... Thus, the movement of the lips may get repeated, but there is no regularity of time here. Similarly, a ball rolled on a floor keeps on moving for a while, but does not repeat its motion after it stops. Oscillatory motion. An object is said to have an oscillatory motion if it moves to and fro along the same path in a regular periodic way. Examples: the swinging pendulum of a clock, a child moving on a swing, a ringing temple bell. It moves back and forth between the 2 points along the same path. Such a motion can be observed in a suspended object for which one end of the suspending thread, wire, or rod is fixed. Here, the object moves as a whole and there is no change in the shape or the size of the object.
Right. So this is the basic concepts of our kinematics. Before going to kinematics, you should know what is exactly the motion and what are the various types of motions which you already learned in the earlier classes. Just I want to recall them so that you can understand the next continuity. What we are going to continue, you can understand clearly when you know about what is exactly the motion and what are the various types of motions we can see in our everyday life. Every moment, you can find the motion, because without motion nothing is there. The lack of motion is death only, as per the Albert Einstein. When body is not moving, what he will say? Dead. As long as you are alive, should keep on moving. Means changing the position. We should not sit at one place. You have to keep on changing position, right? That is called motion. So that is complete about the what exactly the motion is. Okay. Now once we'll see about our material, what exactly given in that, about the kinematics, what we have to learn in the coming sessions. Okay. See here. So this is our topic, kinematics. Maybe the page number can see here, 23 in your material. What is the page number? 23. What we have to learn about the synopsis 1. When you come to the synopsis 1, you have to learn about what are the physical quantities. Just a minute. Okay. We'll cover in the coming days, we'll cover about physical quantities, which already we discussed in the measurements. Next, vectors and scalars. The one classification is there. So physical quantities are divided in two categories. One is fundamental and derived, and the second classification is vectors and scalars. That we'll discuss. Then distance and displacement, speed and velocity, acceleration, and graphs. These are the total topics what we are going to cover in a coming days, that is in the entire week. So where we discuss about the what is the motion, what is the consequence of the motion. When a body is moving, every moving body will have speed. Every moving body will cover some distance. Every moving body will have acceleration. So these are the properties of the body, physical properties come across when body is in motion, right? What is before paper, please? Can I get clarity? So when you are, so maybe this one. Right, maybe you're asking for this or this. Ramnagar. Okay, so whenever you are body is in motion, what we discussed, there are any type of motion. It may be any type of motion. When body is in motion, what will come across? Will come across the various physical properties. Every moving body will cover some distance or displacement. There is a difference is there. It has speed or velocity. It may have acceleration, deceleration, time it covers, it takes some time. All these are the physical quantities which will come across when body is in motion. And these properties will have some relation among themselves. When you give the relation between all these physical quantities, physical properties, we'll get some equations, which are called equations of motion, which are the basic mathematical formulas in physics. Equations of motion. There are 4 equations are there. So that equations can helpful for us to solve the many problems in physics. The first step to solve the problems in physics. Okay. Right. So next we'll see many more. We'll see about the vectors and scalars, and I don't know why this is missing first page. Anyway, right. So this is what we are going to discuss. First, physical quantity, because we already learned about physical quantities. Physical quantities are nothing but physical properties which can be measured. See, when you see this physical property, the first case. So physical properties, physical quantities, we have seen so many physical quantities we have seen in the last chapter. Physical, they are divided into 2 categories earlier. That is fundamental. Second one is derived. Not only that, these physical quantities also can be divided into another category. That we'll discuss in the next class. That is vectors and scalars. Another classification based on their magnitude and direction. Whether the quantity is having the magnitude or not, because every quantity will have magnitude. Magnitude and unit is a compulsory. But having direction is very important. If it is having the direction, it is called vector, not scalar. That we'll discuss in the deep about the vectors and scalars. That is even helpful for you in mathematics also. We are not going that much deep here. In mathematics, there is a separate branch is there called vector algebra, where we learn about the addition of vector, subtraction of vector, multiplication and division. But here we'll discuss only about the identification of physical quantity into either scalars or vectors. We'll identify. How you identify as a fundamental? See, we have 9 fundamental physical quantities. 7 plus 2. Remaining all are derived quantities. Same way, these physical quantities are placed and observed. Which one is having the magnitude or placed under scalars? All the quantities are, no doubt, they are comes under scalars. But out of that, some of the physical quantities will have direction. They are picked and dropped into the vectors. Like that, we get the scalars and vector classification in the next class. See, this is about what given the textbook right now. Introduction to the physical quantity. We have seen already in the last chapter. Right? Under the heading of measurements, fundamental physical quantities, we know length, mass, time, electric current, temperature, luminous intensity, and when you come to the derived quantities, we have so many are there. And every fundamental quantities have the units called fundamental units. Derived quantity units are called derived units. So derived, you can see volume. Volume is there. Length into breadth into height. So many area, volume, density, force, pressure, all comes under the derived quantities, right? So after knowing about this, because you already know this, I have not discussed. We'll discuss about how these physical quantities classified into vectors and scalars. What is the difference between the vectors and scalar, and examples of them. So many. Then we enter into the what is distance, what is displacement, what is the velocity, what is the speed, acceleration. Then we enter into the what is the uniform and non-uniform acceleration, uniform and non-uniform velocity. Then we enter into graphs also. There are some graphs by which you can understand the nature of motion. Right? So next coming days, coming weeks, we can cover so many things in the kinematics. Then we'll enter into the some mathematical formulas also, formulas and problems. So many things you can do. Right? So that's all for today. What we learned so far. Right? So when you come to this part, homework, you can learn. Already might have written some points there. So make it as a homework here. I write the homework on the screen. You can copy the homework now. Actually, I forgot to write here. Now I'll write now. Okay. Take down the homework for today. That is DPP. Classify mechanics and explain each branch. So I gave you on screen for you what is mechanics and how it is divided into kinematics, kinetics, and right. You just the table I have given, that first what you copied is you mention that and classify that into what is kinematics, what is the kinetic, what is statics, and what is the dynamics. Everything I given for you, write about that in your notebook and take the signature from your teacher as a DPP, that is daily practice programs. Hope most of you have done that weekend task I given for you, 20 questions, and might have corrected. Once again, I request all the teachers, please make it seriousness in the IIT Foundation. Let them motivate them to do the homeworks given to them every Saturday. And please, you make the corrections, simple corrections. And maybe make sure that every student is appeared for exam once in a month. What we are conducting very less, but no issue. Just create some seriousness among the students so that they can learn some new things. And they can learn some new things which are helpful for even their regular syllabus also. Right? So thank you very much, students. Have a wonderful day. Thank you. Good to see many branches today.